Hello again, guys. I'm back with hopefully the last example for superposition. And in this particular problem, I want to show you that if you have a situation with a load, and this is only one load here, as you could see, we have a cantilever beam with just a concentrated load acting over 2/3 of the length. And you don't have this case here in the chart, in the deflection. You have the deflection and slope outcomes for a beam with a distributed load covering the entire beam. So the question is, how could we find the maximum deflection at point C? So what I want to show you is that even though you don't have that in the chart, but you could use the information in the chart and kind of improvise and come up with the maximum deflection which happens at point C. So let me show you how that is done. So first of all, how would this beam deflect? So you remember that I did mention that in the previous kind of video, that this portion is going to be a curve of fourth order, actually, if you did it by integration, fourth order polynomial. And then from here, since there is no moment, moment becomes linear. Moment is zero, so deflection becomes linear, actually. So therefore, what we want to find is deflection here. That's y of c. That's what we are trying to find. So what we can do actually, why don't we actually find the deflection here at point B and also a slope at point B? Slope at point B would be a slope of this line also, since it's linear. So two things I want to determine here, deflection and the slope at point B. So theta at B and y at B. And both of those are right here. This is the slope and this is deflection. The only thing you have to be careful is that, and forget about the negative sign again. We know that both the slope and deflections are negative. So let's just concentrate on what we have here. So we have WL cubed over 6EI for the slope. But remember, this is for this beam where the length is L. Our beam, the length is actually 2L over 3. So I'm going to replace my length by 2L over 3 divided by 6EI. And I'm running out of space here, but if you do the calculation here, that should come out to be 8WL cubed over 162EI. That's a negative slope. Okay, let me just move a little bit below this and show you how we can find y sub b. So y sub b is what? Well, for this beam here, it's WL to the power 4 over 8EI. Again, go ahead and replace your length by 2L over 3. So if you do that, to power 4 over 8EI, be careful, guys, with raising these. Like 2 to the 4 is 16, 3 to the 4 is 81. So after you clean this up, you get WL to the power 4 with, let's see, a 16 out here. That would be the 2 to the power 4. And then 81 times 8 becomes 648 EI. Okay, so I think we are ready to move on and show you how you can now find the deflection at point C. So the way I'm going to do this is take a look, guys, here in this picture that this is already what? Y of B here, right? So if I add to Y of B this much, and what is that much? Let me show you what that much is. See, this is theta at B, right? And this is a very small angle in radians, right? What I calculated here is in radians. So if I find this, which I call it Z, by the way, that's Z right here, right? So what would be Z? Tangent of this angle, tangent of theta B, for a small angle, as you guys know, is the same as theta B, is equal to what? Z divided by, and what is that? That's L over 3, right? That's this guy right here. So Z over L over 3. Therefore, Z becomes L over 3 times theta B. So what is L over 3 times theta B? What is theta B? Theta B is right here, right? This guy, 8W L cubed over 162 EI, right? So when you do the multiplication, you end up getting 8. Sorry, I forgot to multiply it by, yeah, let me just actually, yeah, so we get 8 WL to the power 4 over what? 3 times 162 becomes 486, I believe. Yep. So now y of c, which is the y max, becomes what? Becomes y of b, this guy right here, right? Plus z, or y of b, which is right here, plus z. So y of b already is 16 WL to the power 4 over 648 EI plus z, which is 8 WL to the power 4 over 486 EI, right? Common denominator, again, I think the lowest common denominator would be, if I'm not wrong, would be 1944 EI, right? And then you end up getting, if you factor the WL to the power 4 out, 648 goes to 1944, I believe 3 times. 3 times 16 is 48. And then 486 goes to 1944 4 times. 4 times 8 is 32. You end up getting an 80 over 1944 EI. And of course, the numerator WL to the 4. And then eventually this reduces to 10 divided by 243 WL to the power 4 over EI. And that's the answer. There we go. So you see that even though you didn't have this particular case in the table, but you could improvise based on the equations that you had in the chart and come up with the maximum deflection at point C. Okay, hopefully, as I said, this would be the last example of the superposition. The next topic, which could happen next week, the week of the 22nd, I believe, or the 23rd, or maybe earlier, maybe I'll have videos ready before that, would be on using the concept of deflections and deformation to solve problems that are statistically indeterminate. So that means we have too many unknowns, too many supports. Okay, as always, thank you for watching and listening.